Hey, so this is the lab for confidence intervals using a proportion. And so I'm not really sure at the moment if this is going to be the first lab or the second lab. So hopefully you're just bringing all your patience with me because this is about the 8 millionth video I've made this week and I'm going a little cross-eyed. So what you need for reals is this paper right here. I talked about it in the other video. You didn't actually need it. You do need it for this one. This Z-score chart that we have been using for chapter 6 and 7. We're going to be using this bottom corner right here where it says confidence interval, critical values, Z of alpha over 2. And so you can see we have 4 main percents that we're talking about. You can see it a little more clear on your paper than on my screen. 90, 95, 98, 99% confidence intervals. And then we will have the Z value, the critical value listed right there. All right, so we are going to start. Let me just get set up and then I will show you what page we are on. So we are going to start on the bottom of page 76, like barely just the bottom right there. And it says a summary. And it's because I don't really like the notation they use at the beginning of this. That's why I'm kind of jumping in to their overall summary and then we can just do a problem. But the qualifications for this, it's like a binomial distribution. So we need to have 2 choices, a success and a failure. And in fact, we need a few of them. We need a certain amount. In this video or on this worksheet, it says 10 successes and 10 failures. On my other notes, I wrote 5 and 5. And it's just basically like ask more people than your friends, right? Like if you ask your friends or if you're trying to take a survey and you want to know how many people are watching The Masked Singer tonight, I don't know why you would ask that, but if you did and you found out that 4 out of 7 were watching it, that's not really a high percent. Like, I mean, that'd be a high percentage, but it's not really accurate of like the entire population. You know, 4. This would be 4 successes and 3 failures. That's really not that many people in the grand scheme of things. So we want to have a bunch, at least 10 successes, 10 failures. And then once we have that, we want to determine the critical value Z, which I just showed you the table we're going to use. And then we'll use this formula for margin of error. Now 1 minus P hat is the same thing as Q hat. And so another way to say this is our margin of error is Z times the square of E, because it's a critical value just like we did with T. But we could also call this P hat times Q hat over N, because Q hat equals 1 minus P hat. It's the same thing with the binomial stuff we did in chapter 4 with the successes and failures. The whole thing totals to 1. So if you know the successes, then we can subtract from 1 to get the failures. All right, so here we have the ways to write a confidence interval. We don't typically write it this way. We usually write it out as an interval. P hat minus E is the lower limit, and P hat plus E is the upper limit. And then finally interpret, in other words, write a sentence. So to finish up how confident we are that the confidence interval contains the true proportion. Okay, so here we are. We're going to start with number 12, and this is talking about aliens that have been monitoring Earth. And so the question says, how many successes and failures are here? And a success is a student who believes in aliens. So in this problem, we have 159 successes, because that's the number of people who believe. And then we have 599 failures. And that just comes from the total minus our success. That's a 9. 599. Okay, so Are the criteria met? Yes, this is something with successes and failures. They clearly have more than 10 of each. And so we are good to go. Okay, so what is p hat? Well, p hat, the formula, let me just write it off. P hat, the formula is the number of successes over the total number of people. So in this form, 159 successes, and we have 758 people, and so we get 0.210 is our p hat. And remember this book, the way they wrote the formula, they don't actually write a space for q hat, so I'm just going to write a little q hat right here, 1 minus 0.21. So I'm going to get my q hat is 0.79 or 0.790. Okay, so q, I'm so sorry, we're not on q, we're on z. The confidence interval for z, that's at the very, very bottom, we get 2.575. And now I'm going to compute the margin of error. So for the margin of error, I have my z, and I'm multiplying that. I need a bigger square root, but I'm taking the square root of my p hat times my q hat all over n. And so I'm getting about 0.04 on my calculator. Okay, so there's my margin of error. And so again, I guess I should back this up a little bit because that was kind of fast. What I did was I used, for the fraction part, if you type in the square root button on your calculator, you get something that looks like that. And so then you go back to this little box and then you type in the n over d. And so it should look something like this, and then you can start typing it. If you type the n over d first, so this would be the bad way. If you started off with this and then you hit this, go up and you hit the square root button, you're usually going to end up with something like this. And you'll notice in the second option, the square root go to the denominator. So this is bad. Don't do that. You want to put the square root button first and then use the n over d button to get that fraction. And again, just pause it. If I'm going too fast with these calculations, just pause it and then make sure you're getting the numbers and then continue on with the video. And so I want to interpret the margin of error. Well, this isn't really something we do. We don't interpret it. You can if you want, but I'm not too worried about it. What I want to do is, the p hat plus e and the p hat minus e. And so again, we don't use this notation here. So p hat minus e and my p hat plus e, 0.21 minus 0.04 and 0.21 plus 0.04. So I'm going to get 17, 0.17 and 0.25. And so writing it in the notation, smaller one on the left, bigger one on the right, and finally writing a sentence. We are 99% confident that the true proportion of students who believe in aliens between 0.17 and 0.25. Now we don't need to write units here because the proportion is the decimal representation of the percent. So it's like saying 17% to 25%. And proportion questions are answered with decimals, so we don't write it with the percent, but that's why we don't need units, is because it's just a decimal representation of that percentage. So we're saying between 17 and 25% of college students believe that aliens have been monitoring the Earth for years. Okay, maybe. But you'll notice I have the same skeleton that I had with the mean. I have the percent. I have the word proportion instead of mean. And then what is it a proportion of? So I wrote what was happening in the problem, students who believe in aliens. And then finally, the proportion, the actual numbers that we got from this particular problem. All right. Next example, we're looking at these little pigs, and I encourage you to read about this and, what did I do? Look up this pig dice on the internet. Oh, Lordy, where did it go? Maybe this is a good time to pause while I try to figure out. Oh, there we go. We're back. Okay. Yeah, this is actually a funny game where you roll these, quote unquote, roll these pigs, and then you see if they land on their feet or not. And so here we're looking at someone that rolled these pigs almost 12,000 times. I don't know what that was. All right, I don't know why that just kind of rang in the middle. I don't know if it's a continuation. I will figure it out when we're done. But if this is a new video, let's see, let me get my screen shared. There we go. And so here is the second problem. I'm just gonna go kind of fast because I don't want this thing to turn off again. And so make sure you are taking your time to read through this and slow it down as needed. But it says, what's the sample proportion that it lands on its feet? So we know that it is going to land on its feet 1,052 times out of 11,954 times. So that's about 0.088. And so then we want to go ahead and calculate Q hat from that 0.088 by subtracting from 1. And we are getting 0.912. So, I mean, it's no surprise it's not landing on its feet most of the time. It only landed on its feet 1,000 out of 12,000 rolls. So it's a very small percent, less than 10% of the time it's landing on its feet. And so therefore more than 90% of the time, we're gonna go ahead and be able to have it land something besides its feet. Okay, anyways, 95% confidence interval, looking at that yellow paper, we get our Z is 1.96. So we're gonna compute the margin of error, putting our error, our Z, and then the square root of 0.088 times 0.912. And our n is quite large, so make sure our square root is on everything, 11,954, and we're getting a really tiny number, a couple of zeros, and then a 5. So then our confidence interval would be p hat minus e p hat plus e. Our p is quite small, so oopsie, so I need a 0 in there. So then our e is also small. It's going to be pretty small interval. Add point, that's a 5, not a 6. Oh no, where did it go? Your screen is paused. Okay, we're back. There's a 5. And so we are getting 0.083 and 0.093. So those are our two endpoints. Interpret the confidence interval in the context. And so what we want to do is write out our sentence. In this case, we were 95% confident. That the true proportion of pigs landing on their feet is between 0.083 and 0.093. So basically between 8 and 9% would be the proportion. We're 95% confident that the proportion would land in between those two values. Okay, so then doing this again for 99%, we have Z equals 1. No, it's not 1, it's 2. It's that lot, it's that bottom number, 2.575. Compute the margin of error. So you just go back into your calculator, change the E, and the whole fraction part is already there. What was it? It was 0.912. And my hand keeps hitting this and then weird things happen. Okay. And then it was N 11,954. Oops, lost my bar. Plug that into my calculator and I got 0.007. So we had higher confidence, and then compared to last time, we had a bigger margin of error. Last time it was 0.005, now it's 0.007. So it's a bigger margin of error. So our confidence interval still using the same e-hat, so 0.088. We're subtracting 0.007 and adding 0.007. And so we have our 0.088 minus 0.007. I guess I could have done that in my head. Got 81 there. And then 0.095. So just a little wider interval here. 0.81 to 0.095. Up here we had 8.3% to 9.3%. This is 8.1%, 9.5%, so a little wider. In other words, I'm going to be more confident about hitting the target if you give me a bigger target to hit. And the bigger, if I was playing darts, I was hitting that dartboard with only 2 rings on it, I'll be less confident that I would hit the board. Had 4 rings on my little bullseye, throwing a dart at it. The bigger the target, the more confident you are that you're going to hit it. Well, we're not saying you're going to hit a bullseye. We're just saying you're going to hit it, period. If you're just telling me I'm going to hit it, you give me a target the size of a wall, yeah, I'm going to be pretty confident that I'm going to hit it. But if you give me a target the size of a plate, I'm going to be a lot less confident that I'm going to hit it. So the bigger the interval, the bigger the confidence, and vice versa. Okay, so we have our sentence coming up. We are 99% confident. And I'm basically just going to write this whole sentence. I don't know why I'm still writing in red. I don't really like red as a pen color, but I'm going to write the same thing I did for 25, but just with my new percent and my new numbers. So we are 99% confident that the true proportion of, what I say, pigs landing on their feet is between 0.081 and 0.095. All right, suppose someone claims that 8% of the time the pig lands on its feet. Would you say this is possible? And I would say, you know, I can't really say 8% of the time this would happen, because my 99% confidence level from this previous problem started at 8.1%. And I'm 99% confident in that. And so percent is not in our, how do I spell R? O-U-R, in our 99% confidence interval. So no. The claim is not possible. I mean, we're 99% confident in this answer. The 99% confidence interval does not include 8%. Therefore, this claim of 8% is not possible. It's very close at 8.1%, but it's not possible. Which one is more precise? Well, this is the one I was just talking about. Which one was smaller? So the 95% confidence interval is smaller, thus more precise. It's getting sloppy. Okay, which one is more likely to contain the true population proportion? Well, since it's bigger, it would be the 99% confidence interval. All right, now after this, it's going to kind of veer off to a different problem. So I say that that is enough information to get you started on the notes for the proportion for confidence intervals. So that is everything that I have for this section. Sorry if it comes out in chunks. The video kind of started and stopped partway through for both labs. So I'm going to try my best to piece it together. Hopefully it made sense. And yeah, we're going to kind of see how this works for the lab portion. This might be terrible. We might scrap it. We might do something live, or we might do something partner based. I don't know. I'm open to suggestions. We're just going to try this and see how it works. This is all new to all of us. And so good luck, and come see me in my office hours if you have any questions. All right, thanks.